Okay, so John and Steve are playing a game. There's a bag containing 1 blue marble and 3 green marbles. There's also a spinner, 1/3 is blue and the remaining is yellow, as shown here. John's only task is to draw marbles from the bag and replace them, while Steve's task is to spin the spinner. They alternate turns. The game is won by getting a blue via your task. Whoever gets a blue wins, basically. So A part says John is to go first. Well, I know for John, the probability of getting a blue is John is in the bag of marbles is 1 out of 4. And the probability that he gets a green marble is 3 out of 4. This is John. So maybe it's JB and J. Steve, however, the probability that Steve gets a blue is 1/3 from the spinner here. The probability that Steve gets a green, or a yellow, which is not blue, is 2/3. I want to determine if it's a fair game. If it's a fair game, that means the probability of winning is going to be 0.5, or 1/2. So what happens here is John goes first. And so John could either win, which means that he got blue, John got blue, or he lost. If he won, the probability of him winning is 1/4. So therefore the probability of him losing is 3/4. And so then, if he wins, the game is over, done. But if he loses, then it becomes Steve's turn. And Steve could either win, so Steve gets a blue, which is 1/3, or he could lose. This is Steve getting a yellow of 2/3. If he wins, the game's over, but if he loses, then John goes, and he could win 1/4, or he could lose 3/4. He loses. And then Steve goes 1/3, 2/3, and so on. And so if John goes first, I'm going to determine the probability. Let's use John has always been purple, or yellow rather, so let's keep it blue rather. So the probability that John wins. All right, so if he wins, the probability of that happening is going to be, 1/4 plus, he could also win if we take this branch here. He could go lose, lose, win. And so that means that we've gone 3/4 times 2/3 times 1/4. Plus, but we also could recognize if we do this again, this is going to be 1/4, 3/4. We could also come along, and he could come along and do this. He could do lose, 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 win. And so if that's the case, then it's going to be 3/4 times 2/3 times 3/4 times 2/3. So this value squared times 1/4, and so on and so on. Forever is the probability of winning, because we don't actually know if he's going to win. And so what I'm recognizing here is this is the sum of an infinite geometric series, where the R value is going to be 3/4 times 2/3. 3/4 times 2/3. And if I simplify that, the 3's cancel, that cancels, and I end up with 1/2. So the probability of John winning is going to be equal to the sum of this series to infinity. It goes U1 over 1 minus R, which is 1/2, which is 1/4 over 1/2, which is 1/4 times 2 over 1, which is 1/2. Therefore, I know it is a fair game. because the probability of winning is 1/2. Okay, and so we've used the geometric sequence idea, series idea to determine this particular probability. And this was for A part. Now B part says Steve goes first. So that means all of this doesn't happen. It starts with the purple. All right, and so it starts with the purple, and maybe we want to determine John winning again. Well, for John to win, I know he's going to have to go, Steve has to lose, and then him win. But then we could also go, Steve loses, John loses, Steve loses, and John wins. And so on, and so on, and so on. So in this case, for B part, the probability that John wins now is going to be equal to 2/3 times 1/4 plus the probability of 2/3 times 3/4 times 2/3 times 1/4. So 2/3 times 3/4 times 2/3 times 1/4 plus, and it's going to keep on going. But each time now it's being multiplied again still by this value here. So the next term is going to be, well, the 2/3 1/4, the 2/3 1/4 times 3/4 times 2/3 squared, and so on. And again, it's an infinite series. And so if I simplify some of these fractions, well, that's a 2, that's a 1, so this is actually equal to 1/6. I can see now that I'm going to do a sum to infinity, where u1 is equal to 1/6, and my r value is going to be, again, 3/4 times 2/3, which was the same as up here, which is equal to 1/2. So the probability of John winning is going to be u1 over 1 minus r, which is 1/6 over 1/2, which is equal to 1/6 times 2 over 1, which is equal to 1/3. So if Steve goes first, the probability of John winning is 1/3. If John goes first, he has a 50% chance of winning. And so one of the things that the IB likes to do is combine ideas from different topics. And this is a great example of how we have probability and geometric series combined.